So you guys understand the anatomy for the mitochondria. It is C, it's inside the inner membrane. That's the inner membrane. Inside you have matrix. That's where Krebs cycle is happening. Okay, so let's look at glycolysis first. Again, glyco means sugar, lysis breakdown of sugar. You have glucose molecule, it's a 6-carbon molecule. It's broken down into 2 pyruvate molecules, 2 3-carbon molecules. That's pyruvate. It's happening in the cytoplasm. So that's the mitochondrial plasm. That's where this is taking place. And it's producing ATP. So this is the overview. So it's producing ATP. It's happening in the cytoplasm. Glucose is being broken down into 2 pyruvate molecules. So this is more of a, detailed version here. I'm now going to ask you to memorize all the steps. I need you guys to know what's going in and what's coming out. That's what you need to know. Now, we said, so we know the chemical formula for glucose. It's a 6-carbon molecule. So we have 6 carbons here, 1, 2, 3, 4, 5, 6. So that's the formula for glucose. It's going to require some energy to break down that glucose. So it's going to require 2 ATP to activate the glucose. So it's going to need 2 ATP. We need to put in energy before we get out any energy. So it's going to need ATP to break down the sugar. And this sugar is going to be broken down into 2 pyruvate molecules. That's 3-carbon molecule. If you're taking chemistry, you know that the chemical formula has to equal. So you can't just put like 6 carbons in and get only 3 out. So you're still getting 6 out, but you're getting 2 3-carbon molecules. So the activated glucose is split into 3-carbon molecules known as pyruvate. What we have learned so far, we learned in glycolysis, it's a 6-carbon sugar molecule that's been broken down into 2 3-carbon molecules known as pyruvate. And we also learned that you need energy. You need to put in energy in order to break it down. So you need 2 ATP that needs to go in. Then, so you got energy production here. One thing that also comes out is NADH. So you're gonna have 2 NADH molecules that come out of glycolysis. NADH, we learned NADPH last time, so please don't confuse those two. NADH is also energy carrier molecules like Uber. It's gonna carry those electrons to the next step or to electron transport chain. So NADH is like Uber. It's gonna carry these electrons to electron transport chain. So you get 4 ATP molecules, a result of glycolysis, but you have to put in 2, so the net is 2. So I hope that makes sense. I'm gonna say that one more time. In order to do glycolysis, you need 2 ATP. You get, as a product, you get 4 ATP. So the net is 2 ATP. It can happen in anaerobic conditions. If you were bacteria, you would stop right here. There's bacteria in your mouth that's anaerobic. There is oxygen available, but it doesn't use oxygen. So it just does glycolysis. So if you're bacteria, you would stop here. But otherwise you would go to Krebs cycle, that's aerobic respiration. So bacteria that are anaerobic, they only do they only do glycolysis and then they go into fermentation. Glycolysis yields 2 ATP net. So 2 net ATP, even though you get 4, but you had to put in 2, so 2 net ATP. And then 2 electron carrying NADH. Please do not confuse NADH with NADPH. That's also energy carrier molecule, but that's in photosynthesis. And 2 pyruvates. So here, this happened in the cytoplasm. Cytosol is the liquid that's found in cytoplasm. 6-carbon molecule was broken down into 2 pyruvate. And in this whole process that we're talking about, we're only talking about 1 glucose molecule. So then that pyruvate is going to go into Krebs cycle. Before that happens, it needs to be modified. It's modified into something called acetyl-CoA. It's an enzyme or coenzyme. CoA stands for coenzyme. So What happens here, it goes through oxidation step. Again, I'm not gonna get in detail for that. And it's broken down into two carbon molecule called acetyl-CoA. Because you have two pyruvates, you're gonna have two acetyl-CoA. When this happens, it's going to release another NADH. But if it happens twice, then you're gonna get two more NADH. Then it's gonna be ready to go into Krebs cycle. It cannot go in Krebs cycle as a pyruvate. It needs to be modified into acetyl-CoA. That's a two carbon molecule. When that happens, it's going to give you two NADHs because this happens twice for two pyruvate molecules. So that's an intermediate step. Some of the textbooks list it as, a step that goes in the Krebs cycle, but it happens before the Krebs cycle. So it's an intermediate step. So this pyruvate, it's modified into acetyl-CoA. Carbon dioxide is released as a waste product. And that's happening here in the mitochondria. As a product, you also get NADH from acetyl-CoA. Then it's ready to go into Krebs cycle. In Krebs cycle, it's going to release carbon dioxide as a waste product. It's going to give you ATP, 2 ATP to be specific, and it's going to give you some NADHs and FADHs. So let me show you, how complicated this is in a second. So during the Krebs cycle, 2 acetyl-CoA, now again, I'm going to keep repeating this. You have 2 acetyl-CoA because you had 2 pyruvate. The 2 pyruvate came from the glucose. So 2 acetyl-CoA molecules are oxidized. They lose an electron and they turn into 2 carbon molecules. And they yield CO2, 4 CO2, 2 ATP comes out of Krebs cycle. NADH comes out, 6, it says 6 total. 3 come out each time. It happens twice, so that's 6. And then 2 FADH. FADH is also electron carrier molecule, so it just carries electron. So same thing as NADH. It carries a little bit less though. I'll give you the numbers at the end. So this is your input. You had acetyl-CoA that had to go in the Krebs cycle because pyruvate cannot go in the Krebs cycle. Some ADP molecules. So this needs to be replenished. That happens through Krebs cycle. 6 NAD pluses go turn into NADHs. 2 FADs go and they turn into FADH2. These are electron carriers. You get 2 ATP, carbon dioxide as a waste product. Any questions so far? If you need me to repeat anything. I'll give you a table with all the numbers at the end. Just making sure you guys are following me. You guys are following me? Give me thumbs up. Yes, okay. So what happens to glucose carbon atoms during the overall process of aerobic respiration?